Are you
Hello.
recording?
Hello, Class A. Today we're doing review notes. Okay.
Thanks.
I think I can draw the picture for the
No, you
Pythagorean
can't.
theorem.
Okay, see ya. All right. All right, we locked her out. All right, we're good to go. So we're going to talk about Pythagorean theorem first. So again, these are the topics that are going to be on this chapter's test. Again, our test is shorter because typically, we'll fill a lot more of this chart, and we'll do that second half in the next semester. So our Pythagorean theorem, hopefully you guys are comfortable. So our a squared plus b squared equals c squared. And the biggest thing with Pythagorean theorem is knowing which side is c. C has to be the longest side. It has to be the hypotenuse across from the right angle. So we'll do a little example over here. The example I'm choosing, I think, is a tougher example intentionally because this is a really commonly missed question on this chapter test. So something like this. So okay. So this is our triangle we're going to do Pythagorean theorem for. And I chose that weird side length intentionally because of the fact that it's tough to work with that in our Pythagorean theorem. So you're probably going to want a calculator. The biggest thing here is noticing that C is that 9 square roots of 5. Now, don't get this mixed up with our special right triangles. This is not a special right triangle. I do not tell you it's a 30, 60, 90 or 45, 45, 90. There's no special right triangle that there's a good rule for that square root of 5. So just a heads up on that, so don't try to use special right triangles here. So I'm going to do our Pythagorean theorem, and I'm going to call these A and B. But the not equals 9 square roots of 5. Now, we talked about squaring things that look like that before. 9 square roots of 5 squared, you have to be careful about how you guys put that into your calculator. Technically, it's really you're squaring both 9 and the square root of 5. So you should get 405. Is that what you guys got? Yeah. If you didn't, we have to figure out what you're doing wrong in your calculator. So when you're squaring 9 square roots of 5, I highly suggest practicing putting that in your calculator, because that's a really commonly missed question on our chapter test. Anyone need help with that? Let me know. The biggest thing is putting parentheses around the whole thing and then hitting square. So we're going to solve this. We're going to move the 64 over. And I should get 341. And then we're going to take the square root of each side.
No, it's 16.67. We'll pick one of those numbers for right. No, I got it right. I just told her 16.67.
Yeah,
and then I got 18.47.
Okay, I was going to say, I don't know where you're getting 16. So the square root of 341, so a question like this, I'd probably tell you guys to round like 1 or 2 decimal places. This ends up being 18.47, unless you're Abby, and you get something bizarre or you just make up new numbers. And that's the side length for that x. And this one, otherwise your calculator might try to simplify 341, but if I ask you guys to do a decimal, I ask that you do actually round to that decimal place and you're careful about that. All right? Questions there at all? So that's Pythagorean theorem, and there's going to be easier questions on Pythagorean theorem like this, but then there's also going to be questions like this one where you have to square something that's a square root. Okay? So talking about our 45, 45, 90 triangles next. This is a little bit out of order. So our 45, 45, 90, this is one of our ones that kind of is just one of those rules to memorize. So the way we know it's 45, 45, 90, it's isosceles right triangle. So we have the two legs, and then the hypotenuse is going to be the leg times the square root of 2. And the example I'm going to do is one of the ones I consider to be the toughest type of the examples of these, so I hope that's okay, because you should be able to do that one as well on the test, but there might be easier ones, there might be tougher, or not any tougher than the one I'm going to show you guys. So I'm telling you guys in this example that the hypotenuse is 24, and I want to find the x and y. Hopefully you already know something about x and y together, or both of them are going to be the same, right? We know that. So hopefully you realize that we don't have to do anything extra to find our x and y once we find one of them. So in this case, I'm going backwards. So in order to go backwards, to go from the hypotenuse back to the leg, we're going to do what with our numbers here? We're going to do, what's that? We're not taking the square root. What are we going to do? We have to divide by the square root of 2. So to go backwards, we have to divide by the square root of 2. So we're going to take 24, and we're going to divide it by the square root of 2. Now, some of your calculators do a great job of this, and then others of your calculators do not, so we have to talk about what to do here. So if your calculator simplifies this, you should get 12 square roots of 2 for both x and y. So that's going to be our x and y. Now, if your calculator doesn't do that for you, you can always feel free to use one of mine, because they do. Or you can multiply the top and bottom by the square root of 2. So this becomes 24 square roots of 2 over 2. And then 24 over 2 ends up being just 12. So that's our x and our y. They're the same. Are we okay with that? Divided by the square root. Any questions on how to get that to work in your calculator or anything like that? Yeah, it's kind of picky about where like the cursor is.
Oh, so, saved it. Why are you using that one? That's not the right one. You have to use
Divided by,
this one,
yeah.
not whatever this. Don't do this. Do this one. Use this. Or this one. 'Cause it's
And that's the kind of stuff we want to figure out before you guys start the test. To have like an error message come up or some crazy number come up that doesn't work. The test is kind of a late chance to do that. So we're going to look, the next one that we're talking about is 30, 60, 90. So this one, if you guys recall, we talked about a short side. We have a hypotenuse, which is 2 times the short. And then we have the other side, the middle side, we do the short times the square root of 3. Did you guys finally get to work? Yeah, you get it?
I'm just trying to have it.
Oh, yeah. Oh, you were using the wrong square root button. Yeah, there's 2 square roots in a lot of your calculators. There's a square root like this, and then there's like one that looks like this. We want just the regular square root. The little x thing is, it's a different, you can have other roots other than a square root. You can have a cube root, a 4th root. We want the normal root. And so yeah, good questions to ask now rather than waiting till you get to a test and are confused. So let's do, again, I'm going to try to pick one that I consider to be a little bit tougher here. So I have my 30, 60, 90 here. And I'm giving you guys one of the sides is 10 square roots of 3. Now, which side did they give us? Which side is this? The side they gave us?
Oh,
It's the hypotenuse. The short sides are x, right? So they gave us the hypotenuse. So we're starting here. That's where we're at. We want to go backwards, and we want to go to the short side next. So we're going to go backwards, and in order to do that, this is 2 times the short. So to go backwards, we're going to do the short, or we're going to divide by 2. So I'm going to take this and divide by 2. But that's pretty easy to do if you getting comfortable with this. So 10 over 2 is just 5. So we keep that square root of 3 in the problem. All we're doing is dividing 10 by 2. So it's 5 square roots of 3. Then once I know the short, I have to multiply it by the square root of 3 to get the middle length side. So I'm going to take 5 square roots of 3 and multiply it by the square root of 3. 5 square roots of 3 times the square root of 3 is just going to be 5 times 3, which will be 15. And that's going to be my y value here. Did that work for you guys? Does that make sense? Yep. So being able to manipulate these triangles and find different sides and different you know, depending on what they gave you is what we're looking for here. Now I will let you guys know that if it's a 30, 60, 90, it's going to be labeled that way in some way. If it's a 45, 45, 90, I'm going to give you some sort of indication to know that. If it's not one of those types of triangles, you can't use this rule. So then you probably have to use Pythagorean theorem. So just know that you can't just, like there's going to be Pythagorean theorem mixed in there. It won't say, hey, use special right triangles for this. So be careful about that. That's one thing that I think people get slipped up on is when they try to use special right triangles when it's not one. All right, so our next one is our geometric mean. And I have 2 slots here because if we want, like, I can probably show you guys 2 different types of problems with this because there's some that I consider to be pretty straightforward, pretty, I dare I say, like easier with this. And then there's the more difficult ones, I think. So geometric mean, essentially, this is what it looks like. Is typically the same thing shows up diagonally from itself. And the type of triangle we're looking at for that, oops, is a big right triangle that has 2 smaller right triangles in it. And this was a while back now, so it might, we haven't really done this as quite as much. And so the most straightforward geometric mean problem would be like this one, where I would look for the x and I know a and b. So I'm going to show you guys one like that, and then we can decide if we want another one, another example. So let's see. So this one's a little bit different than where I'm looking for the x. I'm going to look for y in this one. But hopefully you realize this is the kind where we try to say, like, what matches up with what? This is proportions. So if I'm trying to solve this, I see that the 8 is used twice. It's used for the middle triangle and then the little triangle. So 8 is going to be the number that's going to show up twice. And a lot of times we do with this is we kind of draw different triangles. So I'm really drawing that 8y and 6, or sorry, the 8y. And then this is 8 and 6. And I say that medium goes with medium, so y would go with 8. And then small would go with small. And so again, the 8 shows up twice, so I write that twice in my proportion. So then we get to cross multiply, and we're able to solve for y because it's just a simple equation to solve. So I divide by 6, and I find out my y is like 10.6 repeating 10.67. Oops. Now I could ask you guys in a problem like this, I could ask you to find some of the other sides now. You could do Pythagorean theorem to find the hypotenuse of that 6, 8, actually it would be 6, 8, 10 triangle. So you could find that other side, like if I asked you for that, if I gave that information, or if I wanted you guys now to find the other side of that other triangle, just know that finding all those different parts is something I may ask of you. Do we need another geometric mean question, like another tougher one? Are we okay? What are we thinking?
Seems good to me.
Abby says she's fine, but since there's a few more of you in here, are we okay?
They're fine.
Well, so one of the things you guys today, we have wind time. I did request some of you guys to come see me, but we also have ram wait time. Part of it is like ACT stuff. Some of it has like kind of set aside for us, but then there's also gonna be homework time. I'm probably gonna be in my classroom today, just kind of sorting out, again, some family stuff, but you're welcome to come see me when we have that time. So if you still have questions, you're welcome to let your Ramway teacher know if they need to email me, or if you want to pass ahead of time, I can give you guys that. So just know that when we have time to work today, you guys are welcome to come see me, okay? So please let me know if that's the case. So anyone want to speak up right now and say are we okay?
I won't judge you, it's okay.
Or she might,
Oh.
just saying that. All right. So our triangle inequality, this one is the one that I think a lot of you guys skip over. And I don't know if I gave your notes, or how many different quizzes can I call it? Our scrimmage back from last time. This is where whether or not something's a triangle or not at all. So is it a triangle is this question. And this is actually an older topic, so in order to be a triangle at all, A plus B has to be greater than C. So for a problem like 2, 10, and 5, I wouldn't want to see if this is a right acute or obtuse triangle. I want to see if it's a triangle at all. What do you guys think? Is this a triangle? It's not. This one wouldn't form a triangle. The two sides, the two shorter sides, aren't long enough to form a triangle. So we wouldn't even want to test to see is this right acute or obtuse, because it's not a triangle. It'd be like, is this a triangle? No, it's like, it's zippy. Like, I mean, it's like, it's asking something that doesn't exist. Like, it doesn't make sense. All right, so questions there? So check and see if it's a triangle first. So on the test, and there's questions like this on there's a question like this on our notes quiz we're gonna do today. So this exact question, this is my first question I'm asking. The second question is if this is yes, now if this is no, we just stop. If it's yes, then we have to go to the Pythagorean inequality. And so this is where if it's right, acute, or obtuse. So if it is a triangle, a squared plus b squared equals c squared. That means it's right. So that's already like kind of set aside for us. We kind of are comfortable with that, I think. The acute or obtuse are easy to forget about. Now, again, I'm going to try and help you guys remember the difference. But that's like probably the one big thing you have to memorize for this test. So to be acute, a squared plus b squared is going to be bigger than c squared. And write that down, and I'll try to, I think I've mentioned this before, I'll try to explain how we know that. So in my opinion, that means c is shorter. So if you're picturing an acute triangle, versus an obtuse triangle. This is kind of saying the C is shorter versus being longer. So this is kind of the way I picture this. So to be acute, the C is going to be less than a squared plus b squared. Where if it's obtuse, the c squared is going to be bigger. And so I think about c being longer. So that makes that triangle look obtuse. Like, so if we're comparing two triangles, the c being longer is what I'm kind of thinking about for that. Now, if it's equal, it's right. But remember, there's also a possibility of this not even being a triangle. So we want to check for all of those cases. All right, so our homework is going to be from our book. Before we do that, I'm going to give you guys an open notes quiz. Reminder, an open notes quiz is where you guys can use your own notes. It's just a way for you guys to see, is this going okay or not? And I might even give you guys the option of like choosing to take the test tomorrow or Friday and like making that choice. But we'll kind of figure that out here as we go. So our homework, and this will be on Schoology, is here. We're stopping at number 12.